Automated code generation. GenAI models generate code snippets, functions, or entire modules based on natural language prompts or existing code context. For example, GitHub Copilot uses OpenAI's Codex to translate developer intent into functional code in languages like Python, JavaScript, and C++. Tools include GitHub Copilot, which provides inline code completions and full function suggestions, TabNine, which uses deep learning to predict entire lines of code across 20+ languages, and DeepCoder, which generates code from input-output examples from Microsoft Research. The impact is that it accelerates prototyping, reduces boilerplate code, and minimizes syntax errors, boosting productivity by 20–50%. AI-powered testing and debugging. This functionality automates test case creation, identifies bugs, and suggests fixes. AI models analyze code bases faster than humans, covering edge cases and performance bottlenecks. Tools include Testim, which offers AI-stabilized UI end-to-end testing for web apps, Applitools, which provides visual testing for GUI consistency, and Debugger.ai, which uses machine learning to trace execution paths and prioritize bugs. The impact is a reduction in QA time by automating 90% of test scripting, ensuring robust software delivery. Intelligent documentation generation. This functionality converts code into API references, user guides, or technical documentation. For example, OpenAI's Codex generates markdown docs by parsing code comments. Tools include Docusaurus, which parses JS.doc comments to auto-generate documentation, and Codex from OpenAI, which creates structured docs from code inputs. The impact is that it frees developers from manual documentation, ensuring consistency and accuracy. Conversational coding interfaces. This functionality allows developers to ask questions, such as how to implement OAuth 2.0 in React, and receive code examples or commands via natural language. Tools include GitHub Copilot Chat, which is an integrated IDE assistant for code explanations and commands, and Amazon Q Developer, which provides real-time coding feedback and autonomous agents for tasks like refactoring. The impact is a reduction in time spent searching documentation and an acceleration in learning. Code refactoring and optimization. This functionality analyzes code complexity, identifies technical debt, and suggests improvements, such as variable renaming and dependency management. Tools include Sourcery, which is an IDE plugin for context-aware refactoring, and IBM Watson Code Assistant, which modernizes legacy systems, for example, from COBOL to Java. The impact is enhanced code maintainability and performance while reducing manual effort. Deployment and DevOps Automation. This functionality predicts optimal deployment times, auto-scales infrastructure, and triggers rollbacks during anomalies. Tools include GitHub Copilot, which generates deployment scripts and CI/CD pipeline code, and OpenAI Codex, which automates infrastructure as code setups. The impact is that it streamlines DevOps workflows, ensuring faster and more reliable releases. Risks and best practices. Transparency is important as GenAI outputs can be unpredictable, making human oversight critical. There are risks of bias and accuracy, as models may replicate biases in training data or generate incorrect code. Security and intellectual property risks exist, as code generated from public repositories may infringe licenses, so compliance is essential. Ethical use is also crucial, and implementing policies to prevent misuse, such as sensitive data exposure, is necessary. Future outlook. By 2025, 75% of developers are expected to use AI assistants. Companies like Mercedes and Google are integrating GenAI into workflows for personalized marketing and code modernization. Emerging trends include customizable AI agents, multimodal models like Gemini 2.0, and domain-specific tools such as CodeWP for WordPress.